So first of all, thank you to be here now, even if it's lunch hour. I'm Tommaso Magro, the product specialist for Electronic Expansion Valve of Carel, and today I'll present the new E5V for Electronic Expansion Valve for CO2, so the so-called E5V-C. First of all, a brief recap on the history of Carel E5V lineup. We started several years ago with the E2V-C valve, our smallest valve for CO2, fully welded for cooling capacity from 0 up to 30 kilowatts. Those valve, as I said, was fully hermetic, and more or less 10 years ago we developed the so-called E5V-C. Here we collected the feedback from the market that the demontability is a plus for the maintenance, for sure, but also for the installation. So 2 years ago, we developed the E2V-Z-C, so the demountable version of our smallest valve. And now we present at Chillventa 2024 the new E5V-C valve to enlarge the cooling capacity, switching from 20 up to 150 kilowatts of E5V-C up to 600 kilowatts of E5V-C. But first, to go into detail on the pillars of E5V-C, a few recap on what Carel offers in terms of lineup for R-744. Yeah, with E5V-C we maximize our solution that comprise also a complete package of solutions starting from electronic controls, the micro-rack CO2 and also the P-rack, but also ejectors, P-drive, supervisory system. All these components for manage the transcritical part of the R-744 circuit. But why we chose in the past to go with this project? Because we saw the growing trend of adopting this new refrigerant due to environmental, regulatory, and also economic factors, also related to the efficiency and also with the versatility in the refrigeration application. Okay, let's go ahead with the pillars. As I said in the previous slide, one of the main pillars of this valve is the semi-hermetic design. Why? As I said, easy installation and also maintenance. And in addition to this, for the E5V-C valve, we developed a unique valve body with 4 different cartridges that can change the cooling capacity of the valve. Yeah, this is for the beginning of the project. And to achieve the high performances needed for this type of application, we use the high performance materials, in particular stainless steel for the shell of the valve, in particular for the body and also for the actuator, to guarantee the typical pressure of this type of circuits. Last but not least, on this slide, the structural and fluidodynamic simulation that we use to design the valve. Yeah, because we need the performance across the entire range of use of this valve. Okay, so we designed the valve using the best material that we have on the market to declare also a long life for this valve. Yeah, here as a target we have the operation tested over 1.2 billion steps with a cleanable mechanical filter that provides also protection against debris, because you well know that in the refrigeration circuit debris can be present and can damage the internal components of the valve. Yeah, about the installation, as I said, we have a demountable version also to help the installer to handle the valve. Here we use the valve with a reduced weight and also in 2 versions. On the left side, I reported 2 pictures. On the left side, a completely stainless steel valve with a stainless steel connection. And on the right side, and this valve is also present on our booth, the version with the copper connection, with the aim of help the installer using this type of material. Here there is another important point, the precise control of the flow rate. As all the other Carel valves, we use as a flow curve the equipercentage regulation to ensure the highest precision that each specific flow regime requires. Related to the refrigerant flow, there is also the modulation. Yeah, this valve works on the principle of the modulation, moving according to the thermal requirements of the system, ensuring continuous and also variable control. Design is nothing if the product is not homologated, and here we use the main international standard for the certification, so these valves are UL and also for sure CE certified. Last but not least, this E5V-C is a stepper valve, as all the Carel valves, and you well know that if you turn off the power for certain reason, the valve cannot move, and it will be a problem for safety reason. But here, if you use the ultra cap, so an external battery, you have enough energy to close the valve and to shut off properly and also safety. I mentioned a few slides ago the material and also the pressures of the typical CO2 circuits. Here, a few details on the pressures and also on the temperatures. Particularly with the pressure, the maximum working pressure of this valve is 140 bar, while the maximum differential working pressure is equal to 90 bar. While above the temperature limits, as the other R-744 valves, we use as fluid working temperatures a range in between -40 up to 70 Celsius degrees, while for the environment, temperature limits are in the range -30 up to 70 Celsius degrees. Few details on the installation of this valve. I mentioned as a controllers the P-rack, but also the micro-rack, also other components, ejectors, supervisory system, speed drives, and so on. The XV valve, the E5V-C, can be used as high-pressure valve, flash gas valve, and also as expansion valve, since the working principle still remains the same. Unfortunately, here I don't have the original presentation that I prepared, but another important point of this valve is the fully modularity and the integration in what we call Carel system. I conclude my presentation. Thank you very much for your attention. And now, if you have questions, I'm glad. Otherwise, visit us at Hall 5, stand 304 and 306. Thank you very much.